In this presentation, we are going to discuss Worksheet B, number 10C, part 1. The question says to choose a method to determine the variance and standard deviation, knowing that the standard deviation is the square root of the variance. As indicated, the symbol for variance, or better said, sample variance, is S with a square on top of it. So when you see this symbol, you've got to say sample variance, and S by itself is the symbol for sample standard deviation, because there's such a thing called population variance and population standard deviation, which of course have different formulas. And let's highlight the fact that the standard deviation is the square root of the variance. It's a measure of dispersion, how different the values are from each other, how varied they are, by how much they deviate from each other. So you can see the similarities in the wording of the name of this descriptive measure and what is its purpose. What is it describing about the data set? To calculate how different the values are from each other, you can go to Weekly Notes 5, pages 2 to 5. Now, when you go there, it will reinforce that you are calculating a measure of dispersion. Measures of dispersion allow us to analyze the differences between the data value. You've got the range, which will give you the difference between the highest and the lowest, the interquartile range, the difference between the upper quartile and the lower quartile. And you've got the variance, and there are two formulas for variance, method 1 and method 2. And standard deviation is the square root of the variance. Now, as you can see, both formulas have the sigma sign. The sigma sign is the sign created to replace the word add. So when you see this sign, you've got to say sum or add or total. Now, please take note, always complete all operations to the right of sigma before you add. In other words, add last. And to do that, you create a table. Before we move on to the calculation of variance and standard deviation using both methods, let's just take a brief pause to talk about the symbols that are used to replace key descriptive measures. Population mean, we are familiar with it already. The symbol is mu, a Greek symbol, a Greek letter for M. Sample mean, the symbol for sample mean is X with a bar on top of it. Population variance is the Greek symbol for S, that's lowercase sigma squared. So when you see this symbol, you've got to say population variance. Sample variance is the English S squared, lowercase. Now, population standard deviation is sigma. Bear in mind, the standard deviation is the square root of the variance. That's the squared have been cancelled out. So you are left with sigma, the S sound in Greek, or standard deviation, and sample standard deviation is the English S. So here's a demonstration of variance using method number 1. Here's the symbol. Variance is equal to the sum of all of this. We must complete that before we add. And what is that? We have to subtract the sample mean from each data value and square it. Do that for each one and then add it up. Now, this formula can also be found in the formula paper in the worksheet. Here it is, variance for raw data, method number 1. So as indicated, you got to subtract the mean from each data value. Here it is done. And then square. The mean, we have calculated it to be 88.9. After this is done for each data value, then addition took place to give us 1112.9. Then as the formula instructs, we've got to put this sum over n is 10, and then divide, and this will give us the sample variance. And to get the sample standard deviation, we square root the sample variance, and we got 10.55. So therefore, the average difference or dispersion between the data values is 10.55. On average, the values differ from each other by about 11, 10.55 approximately. Now we've got the second formula, which is also found, which can also be found in the list of formula. Here it is. It says you got to square each value and then add them up to get this number there. N is already 10 and the sample mean is 88.9. But to get this value there, we have to square the x's, then add last. So here, a table is created called x squared in order to square each x and then do the addition, which is give us 80,145. Put this over 10, which is n, and subtract from the mean squared as indicated by the formula. Subtract mean squared, sample mean squared. When the division was done, we get 8,014.5. When 88.9 was squared, we get 7,903.21. Then subtraction took place to get a sample variance of 111.29. And this was square rooted to give us again the sample standard deviation of 10.55, just to verify that the average difference or dispersion between the data values is approximately 11. Also, you can refer to weekly notes number 5, page 2, and you can get the steps to calculate the variance using method number 1. Here's an example, and method number 2. Here are the steps, and here's an example. And you can also go to the Google Classroom TR6 E2WI for recordings. When you join TR6 E2WI, you go to Map 1-to-1 Recordings, Assignment B, Worksheet B, and here you've got recordings to calculate variance and standard deviation using raw data. There you have it.